Welcome to this class. This session, we are going to test that some functions are harmonic. So the first example. Show that the function u of xy given by x cubed minus 3x y squared plus 3x squared minus 3y squared plus 1 is harmonic. So to show this, because this is a function of two variables, then it means that u of xy is harmonic if and only if partial squared u partial x squared plus partial squared u partial y squared equals to 0. Simply, if the function u satisfies Laplace equation in 2D, because we have two variables. Now, partial u partial x will have 3x squared minus 3y squared plus 6x, and then partial u partial y will be minus 6xy minus 6y. So which means that second derivative with respect to x partial squared u partial x squared will be 6x, and then this one plus 6 partial squared u partial y squared will be minus 6x, and then this will be minus 6. We call this one equation 1, call this one equation 2. Then from 1 and 2, we have equation 1 plus equation 2, partial squared u partial x squared plus partial squared u partial y squared equals to 6x plus 6, and then plus minus 6x minus 6. So this will be 6x plus 6 minus 6 minus 6x minus 6. And clearly this is 0. So that one shows that u is harmonic. i.e., u of xy is harmonic. And then number 2, example 2. We have show whether the function v xy e raised to power x into x cos of y minus y sine of y is harmonic. Harmonic means satisfies Laplace equation. So solution, V of xy is harmonic if and only if partial squared v partial x squared plus partial squared v plus partial y squared equals to 0. So from this one, partial v partial x will be, now we use product rule. So let this one to be our u, all this bracket to be our v. So u prime v plus v prime u. So differentiating this partially with respect to x, we get e raised power x into x cos y minus y sine of y. This is u prime v plus v prime. You differentiate this bracket partially with respect to x, and because it's the only term that has an x, so the answer will be cosine of y, and then you multiply by e raised power x, which is u. And then partial v partial y will be, so this will have e raised power x is common. This term here with respect to y will give us negative x sine y minus this one, use product rule, this one as u, this one as v. So u prime is 1 times v, we get sine y. Because it's a minus and in product rule is positive sign, so we still also have a minus sign. Derivative of sine is cos, so we'll have y cos of y. So it tells us that partial squared v partial x squared. Now this one will still use product rule. So let this one to be u, the other bracket, the rest of the bracket to be v. So u prime is e raised power x, and then differentiating, multiplying by this one, we have x cos of y minus y sine of x, sine of y, plus v prime. Now differentiating inside with respect to x, we have e raised power x, and then here we have just cosine of y. And then plus this part, when you differentiate with respect to x, you just get e raised power x cosine of y. So I can simplify this one as x e raised power x cosine of y minus y e raised power x sine y, plus this will be two of them, 2 e raised power x cosine of y. Call this one question 1. And then let's get partial squared v partial y squared. So we differentiate this one using product rule. So we have not really product rule, so term by term, we have e raised power x, which is common. This term here, when you differentiate this one with respect to y, you get negative x cos of y. This other part, we get negative sine. So when you differentiate sine function, you get cosine function. So negative cos of y. Here, we'll have minus into use product rule. This to be u, this one to be v. So u prime is 1. 1 times cos of y is cos of y, plus v prime is minus sine y times y, so I have minus y sine of y. Now when we open this, we'll have minus x e raised power x cosine of y, and then minus e raised to power x cos of y. And then here, when you open minus, we'll have a minus sign. So minus e raised to power x cos of y, because I have this term and this e raised to x. Minus is plus, and then y, and then we have e raised to power x, and then sine of y. We can simplify this one further. This and this are like terms, so we have minus x e raised to power x cos of y. This will be two of them, so minus 2 e raised to power x cos of y plus y e raised to power x sine of y. So call this one equation 2. Now, equation 1 plus equation 2, 1 plus equation 2 will be now partial squared v partial x squared plus partial squared v partial y squared equals to x e raised to power x cos of y minus y e raised to power x sine of y, and then plus 2 e raised to power x cos of y. So I've written all these terms for partial squared v partial x squared. And then plus these ones, we have minus x e raised to power x cos of y minus 2 e raised to power x cos of y, then plus y e raised to power x sine of y. So that x e raised to power x cos y and minus x e raised to power x cos of y. So this and this one cancels out. Next, minus y e raised to power x sine y, positive y e raised to power x sine y. So this and this gives us 0. And then 2 e raised to power x cos y and minus 2. So this one and this one cancels out. So therefore, this sum is 0, and we conclude that the given function is harmonic. Hence, v of x, y equals to, hence v of x, y is harmonic function. So that's how we prove that a function is harmonic. Thank you.